Hi, today I'm still going to talk about how to use neural network to achieve image recognition. And I'm still going to use the NNIST database where there are 60,000 training image and 10,000 testing image. And previously I have derived the gradient for a two-layer, actually one hidden layer neural network. And for today's video, and I have used one input layer, two hidden layers, and then one output layer, so that as a result, I have six parameter to be trained, and I have derived the gradient myself, and then I'm not going to show the process, but the idea should be similar to how I derive in my a two hidden layer neural network. So if you're interested, you can take a look at my previous video where I put my notes in the video. So here I'm just going to use I'm just going to run the code and then to show and in this video I'm also going to like create an image using I'll just I'll write a number and then I will create and then I will read the image in R, and then I will see how my model is how well my model can recognize the image. So actually before recording, I have spent like 2 or 3 hours to do a kind of like a cross validation to get the number of neuron in my first hidden layer and then number of neuron in my second hidden layer, as well as my learning rate for my gradient, which is the scalar here. So I'm assuming you're already very familiar with all the concepts. So now I'm just going to go right away on the implementation on this. So as you can see, for two hidden layers, I have six parameter, and then I have six gradient that I calculated here. And then here I'm using the I think it's called the stochastic batch gradient, where I assign a batch size here, and then I use the so with 60,000 image training observation. So basically, I'm just doing the gradient descent 6,000 times. So that's the setting, and then for the past 3 hours, I've been doing cross validation. So I get my best my best setting for the neurons is that I have 40 neurons in my first hidden layer, 44 neurons in my second layer with the learning rate 0.5, and then I achieve like 50% of the testing error. So here I'm going to use this setting as my best model for this cost function. So I already read it. I already run the model, and then now all my parameter are already the model that I use this setting to train. So with all my model in the already I have all my parameter trained. So now I'm just going to create an image right away. So I'm going to use the background image as black, so that if I use the white color to write a number, then the white color will be recognized as 255 for the RGB for. So basically, a pixel is a range from 1 to 255. So 255 is color white, and then 1 is just black. So I think the MNIST database is also similar to using the white colors for the stroke. So that's why I use black as my background image, and then white color as my color for the image. So now I'm just going to write an 8 here. Since I take a look at my my testing set, it seems like the number 8 I predict correctly the most. So I'll just use 8 as a demonstration. So if I when I so even if that's the case, maybe my model will return a wrong number. But that's what I get over there. That I have at least 15% of the testing error. So maybe my model will still recognize this number as something else. But now let's just take a look. So I just write down, just store in the. So this is the image that I just wrote in. Okay, one more thing. The MNIST function is using all the image with pixel 28 by 28 pixel. So here, after even if I write it a number in a bigger, like a bigger size of the page, now I'm just converting my image into the pixel of 28 by 28, which is the default version for the MNIST database. So if you have a image that is greater than this this size, then you will probably you'll probably need more than your input layer will probably be more than that. That is just the 28 square. So that's this sizing is from the MNIST database. So if you have a bigger image size, then your input layer will be definitely bigger than this. So that is just 28 square. So in order to recognize an image that is specifically for this model, I need to convert all my image into the size of 28 by 28 pixel. So that's why I need to resize my image in this over here. So now I just wrote this number and then save it as a PNG image. And now I'm going to read it, the image here. Okay. And now let's take a look at the image. So this is the image that I just wrote. It looks a little bit blurry. It is because I resized it. So now this image is 28 by 28. And now I'm going to convert the image into first into a matrix with each entry on each entry is a number between 1 to 255, and then I'm going to you can either divide it the number of 255 just to standardize it, or I think this package is also doing divided by the 255 by default, so I don't need to divide it again. But maybe we can take a look at this. So yeah, of course, for example, like the first 6 pixel is 0 because that region is just black. But if you look at the entire, let's see if we can. So my matrix for the image is. So this should be my image. Okay, so as you can see that there is like a you can see that I'm not sure if it is very easy to identify, but it seems like there is some like a pattern 8, something like that in here. Okay, so that's the image. I just read it that I just wrote, and then I also read it in my R. And I also already trained my model using the setting I get with the lowest testing error. And now let's take a look. Okay, so I already have my prediction for the image that I just inputted here. So I hope now let's just take a look what my model recognized that image as. Okay, it recognized as 5. Okay, so probably there's some error here. So let's take a look. So it seems like it seems like this model assigned the probability for 5 for it recognized like is 88%, it recognized that 88% it is going to be a number 5, and let's say the 8 is just 1%. Well, it is the second largest percentage here. So maybe that's so maybe there's something, maybe there's still something else we can improve our model. Maybe we can try another number. So let me take a look on this. So this is the number I get, and the confusion matrix I get. So maybe let's use number of 5 here. Okay, so let's write the number again in the so again I use background color. I use the black as my background image, and then white as my color for the. So now let's just write number of 5, and then convert it back to 28 by 28 and save it here. Okay, so let's read it again. Okay, so this is the image I just wrote, and then it is inputted in R. And now let's convert it into a vector for this model. And now let's run the model again. Okay, so now I have a prediction here for this image. So I hope maybe, okay, yeah, it recognizes 5. So let's take a look at the probability. So you can see that it recognized 99%. It is going to be a number 5. And then the rest are just very small values. So it seems like for recognizing 5, it is making a good prediction. So how about, let's say we try another number. Let's say maybe 2. Let's try again. Okay, so let me delete this number and then do it again. So again, this model is it's 2 hidden layer neural network. And let me increase the. So what number do we just choose? 2. Okay, so I use the number 2 to change the pixel. Okay, so the MNIST dataset is default for 28 by 28. So that's why we need to convert it to 28 by 28 image size. Let's take a look. This is the number I just create. Convert that image into a matrix format, into the vector format, and then so that I can run the model here. So again, these parameter here. Oh, okay. So A2. Okay. So yeah. So these parameters is that after I derive the gradient, and then I use cross validation to get the best to get, like, not the best, but a setting that it gives me a lowest testing error, which is about 50% of the testing error, with 40 neuron in my first hidden layer, 44 in my second layer, and then with a learning rate 0.5 for the gradient descent, and then yeah. So maybe one way to improve the performance is that maybe get a different scalar for different gradient descent. Maybe that's a way to improve the performance. And I also use a for loop. It takes me like 3 hours to do that. And maybe you can use different number of neurons or different number of learning rates to check to see if there's other setting that can give you better performance. or maybe using different other cost function. So, and then different cost function will give you different gradient for your parameter. So that's some other ways that you can improve, but that's another story. So now let's take a look of our prediction on the image. So I just hope that it will return a 2. Okay, yeah, it returns. So it seems like it recognized this image as 2. And now let's take a look at the probability. So it seems like 99% is this model thinks that the image is a number 2, and you can see that all other so you can see that 7. So it recognized like point 0.04%. Is the model thing is a 7, because like 2 is 2. You have like the curvature or the things on the top with on for the 7 and the 2. So maybe that's the reason that it recognized 0.04%. It recognizes a 7, but it still recognizes as 2. Maybe because there's a line at the bottom. So as you can see that so this is how we can, well, you can there's like you can use a package. There are lots of package in R for the neural network, but here I'm just going to derive it all by manually from all the way from my cost function and then to the gradient, and I use stochastic gradient descent, and I use a cross validation to get my to get the setting, and then I get a so-called better model that to improve my model accuracy. So as you can see that we test 3 images that I just created, and then 2 of them it correctly recognize it. So so maybe so that is from the 15%. So maybe again, like maybe 15% of the times it will recognize. Maybe 85% it will recognize the image correctly, but there's still 50% of the testing error. So so this is a two hidden layer neural network, and then derive it by hand using stochastic gradient descent to train the model, and then I use cross validation to get the setting. So this is a demonstration on how to achieve image recognition in R, and then I'm not using any package. So thank you very much for watching, and let me know if you have any question.